Thank you very much, Lady Moderator. I would like to thank you, everybody, above you, but I would also like to thank you, the people that are translating, because without them, I would not understand. So, the question is, first of all, I would not like to divide Turkey from Europe. For me, Turkey is in Europe. So, recycled material is a very important question, not anymore because of the price, but because it will give the second life, second, third, fourth life of the same material, reduce all costs, resources, and whatever was used in producing prime. How I see it, one of the most important things is that we will need strong support from the governments, we will need strong support for the scientific institutes, universities, and. I must say that I'm responsible for a big part of Europe. I'm working for a long time, 40 years. So I can say that one of the countries when I saw the most capability to develop, to try to develop, is definitively Turkey. So thank you again to all Turkish ladies, most of all, and gentlemen doing this job. So my speech will be exactly coming to the speech of my predecessor, because what we are going to do here, we are giving the way how can you eventually use the material, how can we help the material to be again close to prime. So, first of all, we have to understand where do we start from and where do we want to arrive. There are three important technical issues. We have to take care about the impact values, we have to take care about the presence of non-polymeric materials in a polymer, and we have to compatibilize non-compatible polymers. So those three tasks are usually combined. Usually you might have all three of them. So in order, before you start to compound and or recycle, we have to understand that those three factors are extremely important. In automotive industry, we use almost all the materials. Now I'm not going to give any names or whatsoever. I'm going to say that there is a way to arrive to improve characteristics of materials. One, if I come back to the previous one of the most important is impact strength of the material. Impact strength of the material, in this case polyamide, but it's valid for PA6, it's valid for PA66, it's valid for PA11, PA12. Using certain materials which are nothing else than chemically active or physically polar materials are changing the characteristics. On room temperature, on -20, even on -40 degrees. So again, very important to understand where do we start from and where do we want to arrive. If we speak about materials it's exactly valid for prime as well as for recycled. Recycling is compounding of already used material. So here, in this case, we have a possibility to improve significantly the characteristics, in this case sharp impact, of material even on -40 degrees, if necessary. If we make life a little bit more complicated and we have PA6 with glass fiber, if we have impact value quite low or elongation quite low without any help, in this case modifying agents, we can significantly improve impact strength, we can improve elongation, and of course flexural modulus will go down, it's a natural, but not strongly. Exactly the same if we have PET in polyethylene. What does it mean? We are using post-consumer, it should be PET, but there is HDPE. Without modifying, our impact values are extremely low. With a modifier, we increase significantly impact value, we increase elongation, we increase impact strength. How? Depend again, where do we start from, where do we want to arrive? Attention, it is very important to understand if this procedure could be applied because of the costs. People, usually our customers, expect that recycled material is much cheaper than prime. It's very difficult. This is a nice example of what we did. It's PET metallized with polyethylene. If you do not apply certain technologies, you will have very, very uneven the material, which has extremely low mechanical characteristics. If you use the material, in this case only with 1%, the material will be much, much more homogeneous and will be extremely close to prime material. We can, together, offer the solutions to improve recyclability, to maintaining thermal, and I'm not going to, even up to the chemical resistance. ABS compounding and recycling. I love this diagram because you can recycle ABS in a couple of ways. You can use acrylate, you can use rubber, one type, another. You can use MBS core shell materials. We think that we know that using, in this case, a particular type of the acrylate will give significantly better Sharpie impact, even, and the flexural modulus will fall, but not extremely. Notice also that everything I speak is valid for both room temperatures and also low -30. Then, we usually, in recycling, we face the problem of melt flow index, of the viscosity. Important is to understand what do we want. If we need only to do the modifying without changing significantly melt flow, yes, we can do it. If we need to have very high, very fluid material, yes, we can. If we need to have very viscous, low MFI material, yes, we can. This is the slide that I like very much. Here, it is ABS. Why? Because the most of the work is done in German-speaking countries because they are recycling quite a lot of ABS. We have usually, if you have no modifier, our impact strength will be more or less the same after first recycling, then it will drop, not so much, but it will drop. If we would like to use SBS, is a frequently used material, yes, value will be not bad after the first recycling, but second and third recycling cycles will be significantly lower. If we are using one of the material acrylates, it's not a wonder. This is an acrylate, it will remain. Our first, second, third recycling cycles will be very, very, very close. Our second and third will be close to the first one.
You have 2 minutes.
Sorry?
2 minutes you have.
Okay. PCABS, exactly the same story. Fine-tuning of melt flow index, exactly the same story. Polycarbonate modification, the same story. HIPS, same story. PPA, polyphthalamide, the same story. POM, same story. This is something I like. And this diagram gives that the combination of chemical activity and polarity is giving optimal reasons. Again, extremely important, what do we need? Sharpie impact, melt flow, what will be? Coming that, exactly the same PPS. Foams. We, in automotive, we have foams. We have a technology, and recently we have a very good success case of changing the characteristics of foams, using recycled material for foaming, not only to have a better adhesion, but also to have a better characteristics. Overmolding. Overmolding is not directly connected to recycling, but overmolding is a, by definition, combination of two materials. When you have overmolding on two different materials, PET, P, whatever it is, with fibers, without fibers, we know, or we think that we know, what can we try in order to come back. Gels. We can also help in gels case. We have first to know why do we have gels. Incompatible resins, poor dispersion, yes, we can do it. Golden rule to understand where do we start from and where do we want to arrive. Two mechanisms. Recycling, compound is like playing chess. We have two simple rules, physical and chemical, but the game is extremely, extremely complicated. Please talk to us. We think that we can significantly help to turn recycled material close to the prime. Thank you very much. Teşekkürler.